Hello world, welcome to my channel, Proteus Augustus. I'm an artist, scientist, and American constitutionist. And today I want to talk a little bit about science. This is the second video with respect to how the universe works, and I'm going to be discussing the disk. Now, when you talk about string theory and all, these physicists are trying to explain their experiments, the experimental data, these particle physicists. Now, the most I get out of that, out of those years, are the Feynman diagrams. I think those are very useful, right? But the explanations that these guys are coming up with, they can't prove, number one. And number two, it's taken a lot of resources, right? And if they can't measure it, and really, what's the practical end? We're not going to live inside of a black hole. It's not possible, right? Inside a black hole is not where we are. All right? And with respect to thought experiments, right? Well, I mean, do you believe your lying eyes or you don't? I mean, if these flying discs or these flying orbs are real, and by all accounts, I mean, listen, let's just believe they exist and believe that we didn't make them, okay? Now, that means that a species of being, intelligent being, can manipulate space in this way. So if they can do it, our ape brain should be able to figure it out, right? And over the course of my life, you know, I've gone down a lot of these roads that these other physicists have gone down, not as deeply, right? Because, you know, as an analytical chemist, I was doing my job and stuff, and you know, other things, right? I mean, it takes a lot of time. A lot of these guys are mathematicians looking for physics to pop out at them, like it's a mistake. You know, like Madame Curie walking in the lab and saying, "Oh, look at that, it glows," or whatever. You know, I mean, really, you know, and it takes years, you know, for some people to really get their head around the physics mathematically. And they make their careers out of just talking about it. And it's not really yielding anything in the corporeal world for us, right? But if you believe these ships exist, then you have to understand or accept that there's an explanation for that. And I'm going to attempt to do this on my whiteboard up there. Now, I'm just getting started, right? But I have to use you know, some of the mathematics that's available to me in order to explain how I'm seeing it, right? And whether it's, you know, proves out to be good or not, in the end, it's a piece of art, right? But the calculations are there, and I challenge anybody to challenge. I think I can explain a lot of the phenomena with quantum field densities, okay? And that's basically my theory here, all right? And I'll point out a couple of reasons why at the end when I go through this, where I'm at with this painting. So I'm going to go up to my whiteboard, and I'm going to talk about, you know, what I've done with this painting so far and the quantum field density theory of mine. And, you know, perhaps, I mean, art itself is something that triggers other people's minds, right? So it's not so much that I'm right or wrong, but there has to be another way to look at this. And I've been through all of it, you know, I mean, it's not beyond my comprehension. It's not. Okay, so this is just what I'm saying, and hopefully it sparks maybe in somebody else some ideas about this. But I'm just getting started. I can take it all the way because I've been thinking about how to actually make the ship work. And I'm going to show two controls in this video. So let's go up to the whiteboard. All right, well, first let me say that when I first started this painting, I put out a video called Painting Development. And this field and this field, I was gonna put a pictorial of some other things that have happened. But when I got to this frame and I was thinking about security features, you know, I was already working on all of this. I've been at this for a very long time. And then so in the last video I says, well, I'm gonna just whitewash all this. I changed my mind. So I worked out a few things, and I have them all here, and I want to go through them with you. And this is just how the painting evolved. I mean, that's what happens. The other theme that I was thinking about doing with these two fields here, I could still do. I could do another one, but you know, I could do also something else with those ideas. So what ends up happening is this analysis of the situation just took over. So let me just clarify a few things. That's my Y chromosome. My name was changed by law. This is not multi-worlds. Okay, I'm saying that that is a local clock. And that's what I mean. I'm not going to get into that right now. All right, but I'm just getting started. What I'm saying here is that these local clocks exist, right? And I can explain why the multi-worlds cannot exist. All right, and I'll get to that. In short, basically, I believe that a local clock has a critical value in which it lets all the energy out, in other words, right? It's not an explosion, it's more of an inversion. The space is so twisted, right, that it can't hold all the energy anymore. So there's a critical value. So even if there's a universal critical value where these local clocks go off, right, because basically they're storing all this energy. It's like a can in a watch, right? It's storing all this energy in these supermassive black holes. You get a critical value, they go off, and you get proton condensation, right? Or however you want to look at it, sublimation, right? But I can get to that later. But anyways, this is not multi-worlds. This is not based, I'm not making a comment here at all about the duality principle, right? The perpetual mechanism, like I said, quantum entropy can never be zero. This would seem to be conflicting with this statement here that local clocks will end, right? But what I'm really talking about here is that the quantum entropy of the local clock can get so dispersed, so large, that it effectively cannot operate like a clock anymore. All right, and I can get to how that happens, but the universe can never end. All right, that's what I'm saying here. All right, so I wanted to clarify that. All right, so now what I'm doing here is where I left off last time was on Axiom 7. I said stay tuned. So this is where I start looking at quantizing mass. I want the mass energy, right? I want to know, according to my theory, I'm saying that quantum field densities are what's happening here. And in order to calculate that, even though this seems rudimentary, just it can get more complicated, but you know, we gotta start from somewhere, right? Right? I'm not going to get rid of the spatial component, right? I'm going to keep that in meters. I'm not going to turn it into energy like particle physicists. I'm not going to go there, right? I want to keep my mind somewhat in the corporeal world that I can imagine with this ape brain, right? But I'm going to quantize mass here, okay? So anyways, what I'm saying here, if you look at this, right, I'm going to use E equals mc squared, right, for the gravitational mass, right? And I'm going to divide it, I'm going to say that the standard spatial distortion with all tenses canceled to a uniform sphere where the mass is 1 kilogram and the radius is 1 meter. So what I'm saying is you have this object, this ball, the spherical ball in the middle of space somewhere. This is where we're starting, okay? It's in the middle of space somewhere, right? You can just place it. Why doesn't it move? Okay, inertia. What's inertia? Does it mean not because nothing is acting on it, it's gonna stay there? Well, what does that mean? Right? What I'm saying is the reason why is because there's a sphere of influence, right? There's a distortion of the quantum field based on the quantum field density. And I'm going to calculate the quantum field density in this manner. Here, I'm going to call this the specific quantum field density because I'm standardizing this, right, to SI units. The mass is in unity. Even an alien can, whatever they call it, that's unity. The speed of light is the same in our region of space, right? Now we're talking about the spherical relationship, right? So I got unity for this radius, right? But it's cubed. Again, whatever an alien calls it doesn't matter. I am standardizing this. This is capital Rho for the specific quantum field density, right? And I calculated here. That's to the plus 16. I was, things were messing up on that. Anyway, so now what I'm looking at here is I'm saying, this is a partial derivation, right? This can change based on the change in mass, keeping the radius constant, or changing the radius and keeping the mass constant. So this is a control mechanism. This is a control mechanism. All right? And so what does that really mean? Well, before I continue with this control mechanism, let's move over here, right? So what I'm asking here now is what is the quantum field density of the Earth? Given the radius of the Earth is this number here, and the mass of the Earth is this number here, right? So I come up with almost 5 times 10 to the 20 joules per meter cubed for the quantum field density of the Earth. Now, look at the proton. I'm going to go ahead and take Schrodinger's radius. Okay, I'm just choosing to do that. Bohr radius, I'm not, I'm taking Schrodinger. We'll just do it, and then the mass of the proton, right? So the quantum field density of the proton is 7 times 10 to the 19 joules per meter cubed. That's almost the same quantum field density as the entire Earth. Now that doesn't, so you have to understand that the density is based on the mass energy in that region of space and the effective radius. I'm not talking about the sphere of influence yet. I'm talking about the quantum density itself, right? So you can see here how this will apply, right? Right? Now, I want to talk about the disk, right? Now, some of these ships are orbs also, right? I'm not going to deal with that, right? Right now, I just want to talk about the surface area, the bottom of the ship, let's say, right? And what phenomena is this ship exhibiting in order to counteract even the environmental forces, the kinetic forces from affecting it? And, you know, over the years, you know, I looked at everything everybody else was doing, and I'm like, that's not going anywhere. I mean, does the mass of the ship change? I can't see that. So what are we talking about here? What are the ships exhibiting to us? Right? If you believe your eyes, right, you're getting spectra off of the ship. Right? You're getting spectra. You're getting high energy spectra, middle of the road. You don't see a whole lot of long wavelengths, right? Might be there. Human eye ain't seeing that. Right? So what am I talking about? Right? So I want to know the surface area of a disk, right? Let's randomly say 5 meters. I go ahead and I calculate the area, the surface area of this disk. Right? Now, I want to do that for a proton. Let's say hypothetically, I'm going to slice a proton in half. This is right in half of the proton. And I want to know how many of those will fill up this space. Right? So I can go ahead and calculate that. Right? This is the surface area right here, the quantum field proton. Right? Now, I'm going to say 1 proton per this surface area. Right? How many protons is it going to take for me to fill this entire region under this ship? Now, the disk, all the bottom of the ship has to do, right, is create a quantum field density equal to this to levitate. You know, given that the radius and the mass energy is all exactly what you want. But this ship is trying to figure out, how do I make a quantum field, right, that can distort what this is? And how does that happen? Right? So what I'm saying is that these machines basically, right, are producing subatomic reactions, right, on the surface of the ship. And I'm just saying, let's take a proton just for an example, right? So this is 10 to the 21 protons, 4 times 10 to the 21 protons, right? So what do I do now? Here's my question for you, right? Do I take the quantum field density of a proton and then multiply it by the number of protons, the sum of the quantum fields? Or do I take the sum of the protons and do the quantum field density calculation? And when would this apply? So I ask you to consider this. And this is one of my first proofs about quantum field densities. Right? Let's look at the van der Waals radius. Right? Why is that? Well, they'll say there's a repulsion because these 2 protons have the same charge. Well, what's a charge? Right? What I'm saying is that this is the proton in the middle. And as this proton moves through space, it pulls space towards it. Okay? So this Schrodinger radius quantum field density, all right, creates a sphere of influence wherever this proton is, or wherever an electron is. Okay? So so this proton and this proton are pulling space with it as it goes along. Right? So as you force these 2 protons together, right, that's basically a repulsive force. You know, it can get more accurate later, but let's just say that's so. Right? What's negative? If an electron wants to come into this proton, right, well, the proton is pulling space in. The electron quantum field density is so low, right, it can be pulled in, right, to counteract the spatial distortion around the proton, right? So this is how I'm explaining quantum field density. So here I'm saying that the quantum field density of the proton 1 is equal to the quantum field density of proton 2. Therefore, right, that's why you get this repulsion, right? And, you know, here I'm only talking about the quantum field densities. I'm not talking about the field distortion yet. That comes later. I mean, you can use a lot of the tensor analysis to do the field distortions, but in my argument, space is not flat. It's not flat, okay? What I'm saying is, as the universal quantum field acts like a very weak viscous fluid. So when you put this object in space, right? Space itself, the quantum field itself, exerts itself at all vectors around this quantum field density, around this proton, or around this ball of gold in the middle of nowhere in space. It's enveloped by space itself. That's why it doesn't move. That's what inertia is. That's what I'm arguing. Okay, so the second thing I'm saying is the universal quantum field is the matrix that mitigates quantum equilibria, right? And I'll get into that later, because we have to talk about how are we going to move quanta, right? So in this argument here, what I'm showing is I'm going to use a unit vector space, Euclidean space, right? And I'm going to use the del operator for gradient, right, to explain how I'm seeing it in my mind in order to quantize everything. But I don't want to quantize space. I want to quantize as much as I can. But like I said, try to keep my ape brain wrapped around the corporeal world, because these objects we see, right, these objects do what they do. So let's take a look at this. This is my first control. I'm saying that the change in the quantum entropy equals the del operator of the function of the quantum field density. When you keep mass constant, the mass energy constant, and you vary the radius, right? This is a radial control, right? That's why some of these ships crash. That's one reason. They lose radial confinement of the proton production, right, around the crafts, because the craft has to have the field all the way around it, right? It's almost like drag. It's quantum drag. If your proton production is not filling this area, right, then, and you pull it in, you pull the radial control in, then you start to get drag around the edges, right? And it could start wobbling. You know, so if you lose radial control, that's one way for them to crash. Now you look at the mass energy control, and I'm saying that if you keep the radius fixed and you start pumping up mass energy, right? Now you're going to get propulsion. You're going to get movement when you up the mass production, the mass energy production. So I'm saying, now look at this here. I'm saying let mass energy be quantum energy, because I quantized it, right? Didn't I? E equals mc squared. I quantized the mass. I don't have to let it loose. It's potential energy. These quantum field densities act as potential energies on the quantum field, right? And it comes in at all angles. I mean, at all, azimuths and angles or whatever. So let me move on real quick. So I'm going to change mass energy now. Wherever mass energy is, I'm going to change it with quantum energy. So now, right, everything is quantized into energy except the space dimension itself. I want to keep it that way, right? This isn't particle physics. I don't need to do that, right? Right now, I'm trying to get a visualization into your mind. That's what this art is right here. That's what I'm doing with this, right? So I'm trying to, inspire some thought here also. That's one of my signatures. I usually do this on the margins, but I'm going to leave this on the front. Same with this one. So the question is, when would this condition occur? Well, I mean, if I was to force these two protons together to get a helium atom, then I could, say somewhat. There's some energy loss there, but I could say somewhat now that the quantum field density is added, right? So I can multiply here. But as long as these protons stand alone and they're not forced together, and that's another way, right, to control the mass, forcing these together, right? But anyways, then you have to use this equation here, right? Right? And so over here now, I'm saying duality, right? I'm saying consider this argument. All right, consider this duality argument I'm going to make here now based on quantum field densities, right? What I'm saying is the proton itself acts particle-like, where the quantum field density is, okay? The quantum field affect is wave-like. So the sphere of spatial distortion, right, is really what is causing the confusion here. So, because when you measure it, right, you're distorting the space, right, because you're creating a quantum density, right? And this is my argument for the duality principle, why it seems to be different when you measure it versus when you don't. And there's also spin, right? The thing is that this space around this proton, as this proton or this ball of mass, 1 kilogram mass, goes through space, it is pulling space towards the center of it, right? Because space itself is acting viscously. It's surrounding that whole orb, right? That's why everything tends to be ovular or round in the universe, right? Because this is how space works. After the universe started to cool down, electron masses then could settle down, right, and create their quantum field densities, right? But anyways, so this is what I'm arguing here, right? I'm arguing that I can use quantum field densities and explain these two situations right here, right? But that's where I'm starting. It can go a lot further, right? But the bottom line is, I believe that this works, okay? And I believe that later on I'll use the Feynman diagrams to show the production of how I think the protons are being produced, right? But I don't think you guys know how to make this machine, right? So I'm going to be careful, right? I mean, even if people don't believe what I'm saying, tell me why I'm wrong. Tell me how my quantum field density theory is not quantitative, right? This is quantitative, all of this, right? I mean, if you have one particle spinning one way and the space itself is also turning, not just where the quantum field density is, right? The quantum field is turning with it, right? So any other particle that's traveling through space, let's say another proton or another gold ball or whatever, right? It's pulling space with it, right? And when it comes close to the other object, it's going to influence it. And the fact that its quantum field density is much, much larger than, let's say, that other particle is going to get sucked in, right? Because the space around that quantum field density has been distorted and it has a reach, right? We have satellites up around the Earth, right? That's all calculable. That they all have that calculated. I'm not trying to deny any of that mechanics. What I'm trying to do is explain that, quantum field densities, I believe, is what's happening. And so when you come up here, right, and I says, what I say, this may be a link, the local quantum field and classical gravity. I got rid of time. I'm saying quantum entropy is time. So when I come over here and I change the quantum entropy, either by increasing the proton production or subatomic particle production, right? Or I can keep the production and then control the field confinement, right? And then if I want to move horizontally, that's another control. That's the way to displace it across the machine. That's why if they're oval or round, they still work. It's all the same principle, right? It's just, you want to make things easier or harder on yourself, right? But anyways, that's basically what I have to say about that right now. I mean, I'm going to write all this down, but this painting is basically done. And I'm going to leave everything here. And it looks sloppy as hell. But this is just real time, me slamming it down there and doing this video and trying to record all of this on the planet. I really believe that gravity is not a force. Gravity is the effect of quantum field densities. The quantum field densities distort the space around it. Right? And that's what I'm saying. And that's what my theory is down here. That's number 10. Oops. Oh, I guess I pointed a little bit too hard there. Well, anyways, until next time, think free, be free, and eat free.